Hello, welcome to Microsoft Azure Community User Group. So today we have a new session. So let me just Hemi's not in today, and I brought someone from the community. So want to say hi, Prod?
Hi, my name is Fuad, and I'm also anchoring this with Nicholas.
Okay, so let me just do some housekeeping. So myself. So I'm Nicholas Chang. I'm currently Microsoft MVP and MCT. I'm Senior Platform Engineer at Cadence. You want to introduce yourself?
I'm Fuad. I'm a systems engineer at Trayport, London.
So before we get started, we just do some code of conduct. Would you like to do this?
Yeah. So please be friendly and welcoming to everyone, and be patient, be thoughtful, be respectful and inclusive. Lastly, be open and curious. Ask questions to understand and not criticize.
Yeah. So today for our agenda, we have .NET and ABD. So for our first speaker is Orestis. Sorry if I pronounce it wrong, and Tekorukos. Sorry, and he's a head of engineering at Code Cloud, and he's part of .NET content creating and public speaker. He's doing a session on unlock the power of .NET in the cloud, journey in the future with .NET Asper. And the second speakers, they're doing a duo with Gert Jan, Profos, and Simon Lee from Azure Consultants, which is at Intercept. And they're doing a session on deploying AVD-based infrastructure using DevSecOps and DevOps pipeline. So the next session we have is the 7th of April, and so we have it's not on the list yet. I think it's doing a session on mastering Azure Private Link, secure and private access to your service. And the other speaker is not confirmed. So the other speaker is going to confirm. So keep an eye on the date. So let's introduce our first speaker, Orestis. Let me just. Hello. Yeah.
Hello. How are you?
I'm good, thanks.
Nice to be here.
Before we get started, would you like to just introduce yourself and overview your session that you?
Yes. My name is Orestis Meikopoulos, and currently work as you said, as a head of engineering at Cultivating, which is a mid-sized software house company based in Athens, Greece. And I'll be here today with you to present to you how we can use .NET Aspire to deploy workloads in Azure.
Okay, brilliant. So before we get started, would you like the question thrown at you at the first, or would you like it at the end if there's any question from the attendees?
So let's keep it flexible. So if there's a question, just interrupt me and I will try my best to address them.
Okay, brilliant. So let me just share your screen. Yeah, the stage is yours.
Thank you very much. Thank you. So good afternoon, everyone. It's really nice to be here with you. And I hope you're all in the mood for a journey that involves .NET code. And since this is the Azure Community User Group, more cloud references than a sunny weather forecast, let's say. I guess here is exactly where the fun begins. We will take .NET's flexibility, enhance it with cloud native capabilities, and unleash it on Azure, ending up with something cool, I guess, all powered up by .NET Aspire. This is my LinkedIn profile, so if you want to know more about me or connect with me, feel free. So in terms of today's agenda, first we'll set the stage by walking through what .NET Aspire is. Next up, we will break down its core building blocks. We will then look at how services communicate within a .NET Aspire application. Then we're going to see how your services discover each other automatically. Additionally, we'll explore how .NET Aspire gives you out-of-the-box best practices so you can focus on coding rather than reinventing the wheel every time. And finally, we will look at how to launch our .NET Aspire applications to Azure. So what exactly is .NET Aspire? It is a cloud-ready stack for building observable, production-ready distributed applications. It is delivered through a collection of NuGet packages that handle specific cloud-native concerns. Cloud-native apps often consist of small interconnected pieces or microservices rather than a single monolithic code base, and generally consume many services such as databases, messaging, and caching. So a cloud-native app is a specific type of distributed application that takes full advantage of the scalability, resilience, and maintainability of cloud infrastructures. .NET Aspire is designed to improve the experience of building .NET cloud-native apps. To build and run .NET Aspire applications in your local machine, you first need to have .NET 8 or .NET 9 installed in your local machine. Those .NET Aspire projects are designed to run in containers. You can use either Docker Desktop or Podman as your container runtime, but .NET Aspire defaults to using Docker. To develop .NET Aspire solutions, you can use an IDE or code editor of your choice. For example, you can use Visual Studio 2022 version 17.9 or higher. And it also provides a set of solution and project templates. And to install those templates, you can use the command shown at the bottom of the slide, the .NET new install aspire.project templates. Now, to verify that the .NET Aspire templates are installed, you can use the .NET new list aspire command. .NET Aspire templates are available in two categories. We have solution templates and project templates. Solution templates create a new .NET Aspire solution with multiple projects, while project templates create individual projects that can be added to an existing .NET Aspire solution. You can consider the following examples, like here in this slide. We can create, let's say, .NET Aspire empty app targeting the latest .NET version using the .NET new aspire command. And we can create also a .NET Aspire starter app, which is a full solution with a sample UI and backing API included, using the .NET new aspire -starter command. So a little bit of terminology. We have the app model, which is a collection of resources that make up your distributed application. We have the app host or else orchestrator project, which is the .NET project that orchestrates the app model. And it is named with the .apphost suffix by convention. We have a resource. A resource is a dependent part of an application, such as, let's say, a .NET project, a container, a database, a cache, or a cloud service. We also have the integration, which is either a NuGet package for the app host that models a resource, or a NuGet package that configures a client for use in a consuming app. And we also have a reference, which a reference defines a connection between resources. All of .NET Aspire capabilities are achieved through the utilization of an app model that outlines the resources in your .NET Aspire solution and their relationships. These resources represent projects, executables, containers, external services, and cloud resources that your app depends on. Within every .NET Aspire solution, there is a designated app host project where the app model is precisely defined. The app host project is responsible for orchestrating all applications, all services within the app model. The project itself is a .NET executable project, which references the aspire.hosting.apphost NuGet package, like you can see in this slide, sets the isAspireHost property to true, and references the .NET Aspire SDK. That we can see on the top right of this slide. On the bottom right on this current slide, the image describes an application with two projects and a Redis cache. Each resource must be uniquely named in a .NET Aspire solution. In this case, the container resource is named cache, and the project resources are named API service and the web frontend. The web frontend project, in this case, references the cache and API service projects. And when you're expressing references in this way, the web frontend project is just saying that it depends on the API service and the CAS resources, on those two resources. So in order to present the previous app model we saw and their relationships through code, we can use the presented snippet inside our app host project, where at first we create a new app model builder using the create builder method. Then we add the Redis CAS resource named CAS using the add Redis method. Then we add the project resource named API service using the add project method. We also add the project resource named web frontend using the add project method. We also add the reference to the CAS resource and wait for it to be ready using the with reference and wait for methods. And we do the same for the API service resource. So we're essentially saying here that our web frontend project just depends on both the API service and the CAS components to run first, and then the web frontend can run as well. And finally, we build and run the app model using the build and run methods. So .NET Aspire projects are made up of a set of resources like we saw earlier. We have the add project method, which adds a .NET project, for example, an ASP.NET Core web application. We have the add container command, which adds a container image, such as a Docker image, for example. And we have the add executable command, which adds an executable file, such as a Node.js application. Project resources represent .NET projects that are part of the application model. And when you add a project reference to the app host project, then the .NET Aspire SDK generates a type in the project's namespace for each reference project. Projects also can be replicated and scaled out by adding multiple instances of the same project to the app model. And to configure replicas, we use the with replicas method, like we see on the bottom of this slide. Now, let's see how we define dependencies between the resources of our .NET Aspire application. In this case, in this slide, we see the Aspire demo app project resource, which uses the with reference method in order to add dependency on the Aspire demo SQL Server container resource. These dependencies can represent connection strings or service discovery information. In the current example, an environment variable is injected into the Aspire demo app resource with the name connection strings Aspire demo SQL Server. This environment variable contains a connection string that the Aspire demo app project resource can use in order to connect to a SQL database. It's also possible to have dependencies between project resources, between different project resources, and project-to-project references are handled differently than resources that have well-defined connection strings, like a SQL database we saw earlier. So instead of a connection string being injected into the Aspire demo app resource, now environment variables to support service discovery are injected. So in the example on this slide, adding a reference to the Aspire demo API project results in service discovery environment variables being added to the Aspire demo app project. This is because typically project-to-project communication occurs over HTTP or gRPC in .NET Aspire. So .NET Aspire integrations are actually NuGet packages selected to facilitate the integration of cloud-native application with services such as, let's say, Redis and PostgreSQL. Each integration supports essential cloud-native functionalities through either automatic provisioning or standardized configuration patterns. Most .NET Aspire integrations are made up of separate libraries. One type represents resources within the app host project, known as hosting integrations, and the other type of integration represents client libraries that connect to the resources modeled by hosting integrations, and they are known as client integrations. Now, consider the current diagram that depicts the relationship between hosting and client integrations on the left bottom of this slide. Hosting integrations configure applications by provisioning resources, like, for example, containers or cloud resources, or pointing even to existing instances, like, for example, a local SQL server, and enable the app host project we have to express resources within its app model. Now, client integrations, on the other side, wire up client libraries to things like dependency injection, defining configuration schema, and add health checks, resiliency, and telemetry where applicable. These packages configure existing client libraries to be able to connect to hosting integrations, allowing client-consuming projects such as your web app or web API to use the connected resource. This is an audience question. So if we had some flexibility here, so .NET Aspire reminds us of some other technology. Let's say, I would say, for example, something like Docker Compose. So it's something similar, like Docker Compose, let's say in this case. Now, let's say some things about inner loop networking. The inner loop is the process of developing and testing your app locally before actually deploying it to a target environment. .NET Aspire provides several tools to simplify the networking experience in the inner loop, such as we have launch profiles, which are configuration files that specify how to run your app locally. We have endpoints or endpoint configurations, which are the connections between your application and the services it depends on, such as databases, message queues, or APIs. And we also have proxies, where .NET Aspire automatically launches a proxy for each service binding you add to your application and assigns a specific port for the proxy to listen on. The proxy then forwards those requests to a random port that your app listens on. Now, a service binding in .NET Aspire involves two integrations actually. A service representing an external resource your app requires, such as a database or a message queue, and a binding that provides the necessary information to establish a connection between your application and the service. .NET Aspire supports two service binding types. We have the implicit, which is automatically created based on specified launch profiles we have, and explicit, which are manually created using the with endpoint method. Upon creating a binding, whether implicit or explicit, .NET Aspire actually launches a lightweight reverse proxy on a specified port, handling routing and load balancing for requests from your application to the service. The proxy is a .NET Aspire implementation detail requiring no configuration or management concerns from our side, from the developers' point of view. To help visualize how endpoints actually work, consider the .NET Aspire start template inner loop networking diagram we have in the current slide on the right side of this slide. So when you call add project, the app host usually looks for the first launch profile defined inside the launch settings.json file in code to determine the default set of endpoints. And to specify the HTTP and HTTPS launch profiles, we configure the application URL values for both the HTTP and HTTPS launch profiles inside the launch settings.json file. So these URLs are actually used to create the endpoints for this project. Let's go to the service bindings also. So when defining a service binding, the host port is always given to the proxy that sits in front of the service. So this allows single or multiple replicas of a service to behave similarly. Additionally, all resource dependencies that use the with reference API rely of the proxy endpoint from the environment variable. So consider the method chain we see in the bottom left of the current slide. This actually gets translated, the code on the left side, it gets translated to the diagram on the right side, which depicts that a web browser as an entry point to the app, a host port of 5066, the front-end proxy sitting between the web browser and the front-end service replicas listening on port 5066. And because you have two replicas, we have the front-end 0 front-end service replica listening on the randomly assigned port 60001, and we have the front-end 1 front-end service replica listening on the randomly assigned port 65002 in this case. Let's say some things about service discovery. So the service discovery process is intended to allow .NET Aspire applications to automatically discover and connect to each other. The required settings are provided to the services that are part of the app model based on their references, as you can see in the example on the bottom of the current slide. Here, the front-end project references the catalog project and the basket project. These two with reference calls actually instruct the .NET Aspire application to pass actually service discovery information for the reference projects, which are catalog and basket, into the front-end project in order to be able, the front-end project to be able to communicate with those two services, the catalog and the basket as well. Finally, cloud-native applications often require extensive configurations to ensure they work across different environments reliably and securely. .NET Aspire provides helper methods to streamline the management of configurations for OpenTelemetry, health checks, environment variables, and more. So when you either enlist a project in a .NET Aspire orchestration or even create a whole new .NET Aspire solution, a respective service defaults project is added to your solution. And then, for example, when building your API, you can call the following method inside the program.cs file of the API project, which is called the builder.add service defaults method. And this method actually internally, like we see in this slide here, configures OpenTelemetry metrics and tracing, adds default health check endpoints, adds service discovery functionality, and also configures HTTP client defaults, such as adding standard HTTP resilience handler or using service discovery as well. So enough of talking and enough of theory. Let's see some demo here. So take a look at this, at the architecture on this screen. If you like, also I have this QR code here where you can go and you have all the source code and also the slides for the current the presentation of this slide, and also the whole source code of the solution that you can play with it from on yourself. So this visual represents actually the flow of data and the interactions over our demos components. First, we have the users which interact with our Angular frontend. Here we call it .NET Aspire.client. It's where they enter a new customer's details, including a GitHub username. The client sends these details to our next stop, which is the .NET Aspire .server component. The .NET Aspire .server component is essentially the brains of the operation here. It receives requests from the client and handles the tasks like creating or fetching customers. For creating a new customer, it first needs to validate the GitHub username provided by the client. So if the username is valid, then it passes it along with the other customer details to be stored in our database, which is SQL Server in our case. To validate the GitHub username, .NET Aspire.server component calls the .NET Aspire.api component. And this API will actually eventually reach out to the actual GitHub API to retrieve user information and validate that the username indeed exists. And once it has the details, the .NET Aspire.api component returns the data back to .NET Aspire.server component, completing the validation step. After validation, we persistently store customer information in a SQL Server database. And when then we retrieve existing customer data from SQL Server, the .NET Aspire.server component first checks our Redis cache. If the customer data isn't cached yet, the server puts it there for fast lookups next time. This is a quick and efficient way to ease the load on our SQL database and speed up retrieval. All these components we see here, the .NET Aspire.client, the .NET Aspire.server, and the .NET Aspire.api components are packaged as containers and deployed via Azure Container Apps, which is the hosting platform by our choice here. This makes our application portable and easily scalable. And the container registry you see on the top is where we store the Docker images. Meanwhile, we also have Azure Monitor, which keeps an eye on everything. It helps keep track of application performance, resource utilization, and alerting. And finally, the external GitHub API is where we fetch, as we said, user details to validate the GitHub username our users are providing to us. This is an example of how we integrate a third-party service in a cloud-native approach. This architecture here highlights how .NET Aspire actually combined with Azure services and modern DevOps practices creates a powerful environment for building, deploying, and managing cloud-native applications. So next, I'll show you code and how it all comes together in the live demo. So let me quickly bring here my Visual Studio here. So here you can see the Visual Studio solution. So if we have the app host project, which is the orchestrator project, where all
sorry, can you zoom in a little bit? Thank you.
It's a little bit difficult for me, but when I open the source code, I will zoom in.
Yeah.
And now it's very difficult for me.
Okay, sure.
Sure. So here we have 3 projects. Basically, we have the API project, the client and then server project, which is the client is the Angular application. The server is the let's say the server side of this client application, the Angular application, and the API is the thing that actually goes to GitHub to validate the GitHub username. So let's see what is the most interesting part of this presentation, the app host project. Here we can see the program.cs file of the app host project. Is it good, this zoom in that I have right now? Nicholas, can you?
Yeah, that's fine. That's fine. You can see it.
So here I'm trying to create the application model. So I create this builder here, and I'm just saying that. So I need basically an Azure SQL database for my demo. I need also a cache. I need an Aspire demo API, which is the API that will go actually to GitHub to validate my GitHub username. This is the Aspire demo application, which is the thing that actually does all the logic, the business logic here, let's say. And this is where I say that, okay, let's run also the client application, the Angular application, when I run it in my local environment, like in this case here. So in this case, for the customer DB, like you can see here, this is also for the application insights, so the Azure Monitor component, where I say that I need an application insights resource in order to have all the telemetry, all the metrics and the logs for both my API and the server applications as well. Here I'm also saying that for the customer DB, whenever I publish it to Azure, this is going to provision actually an Azure SQL Server component in Azure. But when I run it locally, it will run it as a container, like you can see here. Right now, I'm actually running this application. So as you can see, I have both a SQL Server component, a container running, and also a cache, Redis cache component running as well in my local environment. This is because I have this run as container and also this run as container as well for the cache. When I run it locally, this run as container actually gets triggered. But when I publish that to Azure, then this Azure SQL Server and other Azure Redis code will be actually run. And this will provision actually an Azure SQL database and Azure Redis cache, like we will see in a bit. Also, we have the Aspire Demo API component here that I say that I need a reference to the application insights resource in order for me to go to all those logs and metrics to go there for me. And also I have the Aspire Demo app, which I say has a reference to the customer DB, has a reference also depends on the cache component, also depends on the insights, the application insights resource, and also depends on the Aspire Demo API. So in this case, I'm saying that the Aspire Demo application can actually communicate with the customer DB, with my cache, and also with my Aspire Demo API. And also I'm saying that it has also external HTTP endpoints to say, okay, I will just be able to go there from a public endpoint, let's say. This is, when I run it, this is what I get. So this is the global Azure.NET Aspire, let's say, demo. So I have these containers, the Aspire Demo SQL Server and the cache. I have the Aspire Demo client executable, which is my Angular application. And I have those two projects, the Aspire Demo app and the Aspire Demo API. So when I go here, you can see, for example, I have the Open API specification for my .NET Aspire.server endpoint. And I also have the Open API specification for my .NET Aspire API component. If I go here, for example, and I remove this one, this will redirect me to my Angular application actually. So this is the end application where I have my customer here, and I can create a new customer, for example, let's say Jane Doe, and this is the GitHub username, for example. let's say something that exists. So new customer created, and I have those 2 customers right now. So this is the end, let's say, application for our case. And let's go here in the global Azure, the dashboard for the NetAspire component here. So as you can see, I can do a lot of things here. I can go to the logs for the Aspire demo app and see all the logs here for my Aspire demo app, let's say, resource. I can also change the resource and go to the API, for example. That you can see also that GitHub got actually, the GitHub API got actually, I called the GitHub API to validate the string, let's say, value that I sent to the GitHub API. I can see traces about what happened here, for example. Here would create a new customer. You can see all the traces for the request, let's say. The NetAspire.server component actually got called at first. Then the GitHub, the NetAspire API got called. Then we had a call to GitHub, let's say here, and then we actually stored the end result to our SQL Server component. And if we see also, let's see a little bit about what happens in Azure. So here is the resource group that I have for this demo. So we have the container registry where we have stored all the Docker images used for our solution. We have our container app environment, our 2 container apps, the Aspire Demo app and the Aspire Demo API, the application insights resource, the SQL Server and the SQL database, the Azure Cache for Redis, and the managed identity, which is used by both the Aspire Demo app and the Aspire Demo API in order to be able to connect to cache, to Azure Redis Cache or the Azure SQL Server, let's say, for example, in this case. We have 2 ways we can provision this infrastructure here, and I have this. This is the GitHub repo that I have everything, the code that we saw today, and also a very detailed README how you can also do this yourself. So we have 2 ways actually. We can actually spin up an Azure terminal here and execute the following commands: the AZD init. Then we can. This will actually create a lot of files, let's say, for us. Here I actually explain to you what each file actually does and why we have it. Then we can do an IAZD auth login in order to be able to authenticate to our Azure environment. And then once authenticated, we can use the command AZD app in order to provision all the infrastructure we saw and actually deploy the application. And also we can do AZD down in order to tear down the whole environment for us. We can also generate bicep from our .NET-Aspire app model. We can use those 2 commands, the azd config set alpha.infrasynth on and also the azd infrasynth commands. This actually will create a lot of files for us, the bicep files, for example. So we can actually maintain the infrastructure as code, let's say, for our solution in our version control, and we can tweak it as we like. And after we do that, we can also use a GitHub Actions workflow file. Like, for example, in this case, we have here this one for GitHub, where actually we will actually install the AZD, install .NET, then log into Azure using the federated credentials approach, and actually run AZD provision and AZD deploy command, which the AZD provision actually will provision the whole infrastructure, and AZD deploy will actually deploy our application to the provisioned infrastructure. And I was actually explaining this also to you. This is from my side for this demo. Again, you can find all the source code in this GitHub repo. And let me go to the slide as well. This is the slide in order for you to be able to scan the QR code in order to be able to go to the GitHub repo. Thank you very much, and I'm here for your questions.
So we've got no question, but I've got a question for myself. How can you protect those APIs, like whether it's from .NET Aspire or different APIs? How do you normally secure it?
In terms of security, it doesn't really change anything. So .NET Aspire is like just is a tool to help you provision the infrastructure and deploy the application with ease in Azure. You can use the same techniques that we use for let's say a regular .NET API, for example. It doesn't really change anything.
Okay.
I also have a question.
So you can use key-based authentication or something like OAuth2 or something like that to be able to secure your API.
Yeah, sure. You got any question, Frog?
Yeah. What would you say are the differences between the .NET Aspire and Docker Compose, as you said?
To be honest, for me, .NET Aspire is a lot more, flexible, and also it's a lot more, you can use it actually right now. It's in a very good position in order to be able to go in production with this setup. The Docker Compose is like mainly for local development, let's say. So for me, .NET Aspire is like a very complete solution right now in order to use it to go and deploy infrastructure and applications to Azure.
Okay. So got no more question, but we can ask the other speakers if they got any questions. So, Simon, I'll bring the rest. Got any questions for any .NET Aspire questions? Just
No, not really, because the .NET side of thing isn't really what I specialize in, or I'm not really like from a developer background. I'm more ops and infrastructure. So it was really interesting, but yeah, I don't really have any specific questions to ask.
Kurt, have you got any question for?
No, I really loved the session. It was interesting, but I have no questions furthermore.
Okay, brilliant. So we've got no question. It means that you explained it well. Yeah, so thanks. And I think if you want to send me the link, I just post it and attach it to the link as well. So just in case we won't scan it. Okay, thanks.
Sure.
So the next speakers is going to be, let me just move. Yeah, so the next speaker is going to be Simon and Gert. So before we get started, do you want to just introduce yourself and then tell us an overview of your session?
Yeah, if you put the slides up, we've got some covering intro slides to go through. And yeah, we can kick off.
Yeah, so you can share your slide then when you're ready.
I will do that.
There you go.
So, good evening. Welcome to here. And my name is Gert-Jan Poffers. And tonight we are going to tell you something about deploying Azure Filter Desktop using Azure pipelines. That's our presentation of this evening. And let's start with first introduce myself. My name is Gert-Jan Poffers. I'm 39 years old. I'm an Azure consultant working at Intercept. It's a company in Zwolle. I live in Hardenberg, a small country in the Netherlands. And I'm specialized in infrastructure in Azure. And my main focus, it's not my main focus, but my specialty is maybe Azure Virtual Desktop. I built it a lot in the past and also nowadays. So that's something I want to talk about. You can follow me on the LinkedIn, on the socials, it's being shared on the presentation. And if you want to keep in contact for me, send me a message or visit my website.
Cool. Thanks, Gert-Jan. So yeah, I'm Simon. I'm a colleague of Gert-Jan's at Intercept. I've been doing Azure for like 3 years now, I think, almost 3 years and 6 months. Predominantly specializing in like infrastructure as code, bicep automation, DevOps, and GitHub Actions, and doing lots of fun stuff. And today we're going to go through and walk you through some Azure DevOps pipelines and how you can get it all set up with ABD that Gert-Jan spent many, many hours and tireless nights troubleshooting and building all this stuff. So we thought from a community point, we'd, give back because that's what it's all for. So this is our take on building stuff. And by all means, take the stuff that we've built, or I say Gert-Jan's built most of it. I've just been there and watching him build the pipelines. But yeah, hopefully it'll help you get started if you need to, streamline your AVD deployment and bits and pieces. So here we go.
Cool. So let's start with the beginning. What is an Azure Virtual Desktop? So I think we all know knew the RDS environments we back in the days that we have a terminal server environment built on premise on a hypervisor on a VMware server. You have the session host, you have the RDS brokers, the gateways, all to have some functionality for your work employees or for yourself to collaborate with each other on a shared environment. Azure Virtual Desktop is the successor of that cloud native solution in Azure. In Azure, you can probably compare it with the same environment as the remote desktop services, but all in one jacket. So the licensing, the remote desktop gateway is built in Azure on the background, and you will have the same capabilities when you log in on the forefront. So you can use that in multiple scenarios and in different types. You have the personal one and the shared one. The shared environment, the personal desktop environment is mainly for developers that need a separate desktop. And you have the shared environment, and that can be used for shared environments. Yeah, offices, financial departments, also. In the construction departments, you can name it. For every solution, there's a possibility. For every question, there's a possibility. So yeah, it's a very handy tool. The main capabilities you can use Azure Virtual Desktop for is using the multi-session for Windows 11. Or you can also use a Windows Server OS operating system for that. So the possibilities are endless with Azure Virtual Desktop. So back in the days when we started building Azure Virtual Desktop, you do it through ClickOps. And there's one thing we don't want in IT is that do everything with ClickOps probably. So we thought about a solution to build this all automated. And the best way to do it is to do it from infrastructure as code, but also you also need to deploy your infrastructure as code. You can use it through a deployment script, but you can also use that using DevOps pipeline. So what is Azure DevOps pipeline? An Azure DevOps pipeline is an automated process to build, test your infrastructure as code in the Azure environment. And how can you run the Azure pipelines? You can use it using self-hosted agents or Microsoft-hosted agents. The self-hosted agents is mainly agents you can use that you need to control yourself. You need to build that. You need to maintain that. You need to monitor that if everything is working correctly. But you have more possibilities when using your code. For example, if you have a pipeline that their job is running more than, let's say, 60 minutes, and you use the Microsoft host agents, you will have some boundaries. So in that solution, that it is nicer to use a self-hosted agent. And of course, if you use the Microsoft host agent, is fairly easy because Microsoft is maintaining that, and you don't have to look at the maintainability of the agent itself. So yeah, that is the reason why I use the Azure DevOps pipelines to deploy an Azure Virtual Desktop. And there are many other capabilities, and I will show you that in the code and in the pipeline itself. And it's also the next slide. So why use a pipeline to deploy Azure Virtual Desktop? Mainly because you have your own control when deploying Azure Virtual Desktop. So one of the best advantages of using, for example, infrastructure as code is that it's reusable. So if you build your code, it's reusable. So if you wanted to deploy it to another environment, you can use the same code to build the same environment. If you do that in combination with an Azure pipeline, you will have in combination with, for example, an input variable. Let's say if you want to deploy it to a prod environment or to an ACC environment, an Azure pipeline will give you the opportunity to do that with a drop-down menu or through a radio button or something like that. So for the ease and for the reusability and for the disaster recovery opportunity, a pipeline is very nice to have when you are deploying an Azure Virtual Desktop. After this slide, I will give you some deep diving in the infrastructure as code itself, and I will show you the YAML files. I will show you the bicep file. I will show you the ins and outs of the files. But mainly we have the bicep. The YAML files contain the bicep, Azure CLI, Bash, PowerShell. And all of those files you can find on my GitHub repository, the bicep image automation. So if you want to test, if you want to deep dive in the YAML files, check that GitHub repository, and so you will have more insights. So let's go to the YAML files and the infrastructure as code. First, we have the avd.bicep file. I've created an. Can we see the code, by the way? Is it? Can we see it? Or
I think you're on.
Zoom in. Yeah, you may need to zoom in a little bit. I already see it.
I cannot zoom in, Nicholas. I will do a little bit of zooming in the website itself when we go over to the YAML files. I can show you for now. So first of all, the avd.bicep. In this scenario, we will build an avd infrastructure that's containing not only the Azure Virtual Desktop but also a shared image gallery to store the image in. We are going to deploy an image template. That's mainly the image template will build your AVD image. That's a cool feature from in Azure from Microsoft that when you have some customization being done in the image, like FS logics or time zone redirection, or you want to delete the Xbox apps in the environment because it's not needed for work, you can use that predefined scripts and predefined image template in Azure Virtual Desktop. And it will basically build the base image for you after that. I can show you how it's work after this. So we're building a bicep in Azure Verified Modules. Why Azure Verified Modules? Because that's I think there are really nice modules built by the community that are mainly web aligned and easy to use. First, we build a resource group. We build a network security group, virtual network for the AVD. We build a user assigned managed identity for the image template. To create the image template, we built a shared image gallery. Here's the image template itself. Like I said, you see the FS Logic predefined scripts already in place, and you can also build your own scripting on that. If you have a storage account where you have a custom script and you place that in the storage account, then you can call it in the image template as well. Then you create the AVD host pool, of course, the application group, the workspace, the storage account, and the availability set. That's for the image for the AVD bicep itself. And if you go to the YAML file, that's basically the YAML file. Deploy AVD infrastructure, and here are the input. So I built my YAML file using input variables. And why I use input variables? Because I want to have control over how and where I build my environment. So I have some predefined names already in the input in the input variables. But I have also control to say, hey, I want to deploy in prod ACC dev test. I will deploy in West Europe and North Europe. And of course, you can also use other locations if you want. I have set some predefined image versions. You can also use the 2025 if you want, or the Windows 11. If there is a new version on the market, you can place that in it as well. Then the YAML file will do some stages, validating inputs. We'll do some installation of some necessary packages. It will log in, do a first login test on the environment, and then go to the PowerShell stage to create the bicep deployment. Normally, in a bicep deployment, you want to use a bicep param file, or for example, use the values mainly in the AVD, the bicep file. And in this case, I use the bicep param file. I generated in the pipeline as well. So you see some values being generated based on the input variables for the naming convention. So that also the code is reusable, and you can use it over and over and over again with different environments. The names will never change. So that's the main focus for us, I think. Is reusability. And after that, you will see the AC deployment subcreate, so it will deploy in the subscription, and it will, as a template file, pick up the bicep param what's being generated in this step. So, how does this look in the DevOps environment? Let's go over there. Then we have the and I've this already pre-set up. These are some YAML files I will use in my test environment. Build AVD, for example, is the one I showed you for in the Visual Studio Code. So how do you set this up? For this, I have set this up using workload identities. You can create that. If you go to the project settings, service connections, and say new service connections, Azure Resource Manager, and then you can point to give it a name. It will automatically give the necessary rights to your environment. I already set it up using the AVD pipelines name. And how to create a pipeline. Can also show that is then if you have created the pipeline, and you will also see, by the way, that I use the AVD pipeline workload identity also in my YAML file to authenticate to the environment, to my Azure environment. So if I now say new pipeline and I say Azure repos git, and I can then select all my files I have already put in my repo. So after that, you say continue, and I have it already preset, so I will not do that for now. Keep in mind, if you set the first pipeline up, you always need to give permissions to the pipeline to use the pipeline. But for example, if I now say build this one, just deploy AVD infrastructure, and I say renew, then you will see that I can deploy to a sub. I will set in my Azure subscription. I say my product type is AVD. That's basically for the naming convention. I can say I want to deploy to prod ACC dev test. I will choose now ACC. Then I will set up my VNet and deploy in the location West Europe. For now, I will say, hey, I want to deploy in West Europe using a new VNet, but you can also alter the YAML file that is being deployed in an existing VNet if you have already an environment. It's all up to you. Then I say the base image, and we will run. And for now, it's being it has started. It's a little bit small. Sorry for that. I will zoom in. It validates some packages. This will not take that much long of time. I think with 5 minutes it is deployed the AVD environment, the base AVD environment. So now it's going to check and install the necessary packages.
And I think this is a really good point to point out, or sorry, a really good time to point out that if you were using a self-hosted agent, you could skip most of this package installation bit because you would have all the packages there. Whereas because these are the Microsoft hosted versions, they obviously have the base image in, but then we're installing other bits and pieces to be able to build the custom bicep parameter files. So yeah, you could save a couple of minutes by pre-building and using your own image rather than the Microsoft ones. But it comes down to that whole management overhead. So if you're not pressed for time, you could just leave this running, and it means that you don't have to manage the security and the patching and the image updates of those images. So this is why we're doing it this way for now, because it's not time critical. It can just sit and run, and it runs once, twice a month at best, maybe. Jan, to just build the new.
And especially some parts running a little bit more, but for you don't deploy a base environment every day on the same environment. So it depends on the action you want to take, I guess. So as now you also see that it generates the resource names. So if I do a refresh on my environment, you will see the AVD ACC resource group, and it's spinning up the resources for now. So it's a good thing that the demo gods are working right now. So you have a question?
Yeah, I get. I wanted to ask on the Microsoft agent that you are using. Are you using like a Windows OS or Ubuntu? Or which one are you using?
Yeah,
good question.
Yeah, that's a good question. For this, I'm using Ubuntu, and I also saw that as of today, there's some deprecation in the Ubuntu. So, but you can use both. But for now, I use Ubuntu. Yeah.
Okay.
So it's now finished as of now. So the first steps are being made to create your AVD environment for now, and this is all output. But in this case, I have created an availability set, a shared image gallery, an image template, managed identity, the virtual desktop, ACC pool, and the workspace and the application group. I've also, based on these examples, I also have created some other pipelines because you can deploy the base environment, but yet that's not a working solution. You need to have the image in place. So I have also done that with deploying and creating the image version. It's basically spins up the image template using the AZ image builder list. What this process is doing is that it will look if there's a template available in the resource group we have created. So it's all using the same input variables. And based on that information, it will start the image building process. And after that process finishes, it's a long process. It takes, and it also depends on all the scripts you have put in place there. But it can take up to 30 or 45 minutes. But after that finish, you will have a new version in the image gallery, and that's usable for Azure Virtual Desktop to have as a base image. So I can spin that up, but let me. So I can show you how it's being done on the. So I have now say this is the one create image. So basically I use the same input variables instead of all the VNets. I only say, hey, I have something in the AZ environment. Grab the latest image in this resource group, because on the back end it knows where to go. And if I say run, then it will do exactly the same process. And I will do a refresh on, because I will not finish this for this demo, but I can show you it's being started, because you are now seeing the build run state empty. So it's doing the same thing, checking the necessary packages. Like Simon said, if you're using the is all not needed, but in this case it is. The next step. Always takes longer when you look at it.
It does.
So now going to the next step, create the image. You will see probably not much in the output. We can check the. So now in this step it will list and run.
And it was this pipeline, wasn't it, where you worked out the timeout thing?
Yeah.
Was it?
No, it's not. No, not in this one. I've created. It can be this one, because sometimes in this pipeline, let's say if you have multiple scripts, normally with a few scripts it will cost you, let's say between the 30 and the 45 minutes, something like that. Yeah. But if you have more custom images, then it can take up more than an hour.
Yeah.
And if I had I had it several times that my pipeline was failing, but the image process is still running. So it's not failing the process; it's failing the pipeline. So if you use then the hosted the self-hosted agents, then you can skip the step. Or what you also can do, but not in this one, I have also a Windows Update part for the images, is to do multiple jobs in one step. So if a job is less than 60 minutes, it will also work. But you need to split the jobs into multiple little steps if you don't want to use self-hosted agents.
Sure. And I think that's a really good point that you also just made, was that the fact that even if the Azure DevOps pipeline times out, the actual image build and update, because it's obviously the separate resource running in Azure, will still run. It's just the pipeline that times out because obviously because they're free, other people want to be able to use them or need to be able to use them. So yeah, if you've got longer running jobs, use a self-hosted one.
True. So you should see now that the build run state is running building. So this will probably take 30 till 40 minutes. I will not wait for the end, but you see that it is now being running. So it will also show you that it's now being saved in this gallery with this timestamp. Also based on the input variables we put in place in the YAML file. So yeah, it's that's what I want to show you as of today. I don't know if you have more questions, Simon, about this process.
No, I don't at the moment. Do we have any other questions in chat, Nick, across the other platforms that you're streaming to at the moment?
More question. Yeah. I have one more question. I don't know if you can hear me.
Yeah, sure, go for it.
Yep. So basically, if we're using a self-hosted agent, I'm sure like you need to install the Azure DevOps agent and stuff. Like my question is, which other like software will you need to install? Will you need to install like Azure CLI to connect to Azure for the agent and stuff like that?
Yeah, so the only packages that you would need is Azure CLI, PowerShell, and obviously the Bicep extension of AZ CLI to be able to do that. But yeah, and Gert-Jan's also written some blog posts around this as well. So he's got a whole series on AVD and pipelines, which is where this whole thing kind of started. And then between the two of us, we've sort of turned it into like a co-hosted talk thing where it's now got live demos and all sorts of fun chaos happening live in front of people.
Okay.
Yeah.
How long does it typically last, this deployment? Because it's been 3 minutes. Is there any way to speed up the process, or
No, it depends on how
on
much you're putting into the image as well. So if you've got like the Office suite and various other like visual, like full fat Visual Studio for doing web dev stuff, that can be like gigs and gigs of content that needs to be streamed into it. So
Exactly.
yeah, as big or as long as or as short as you want to make it, depending on how many packages and how much image customization you want to be able to do, really.
Okay, so in terms of cost, how much does it cost overall? Do you know?
I was about to ask that. Like in terms of like for the self-hosted, I'm guessing that's free, right? Or is it?
So for the self-hosted agents, you need to have the consumption of the virtual machine you put in place on that one. So you will have the virtual machine consumption itself. For the Microsoft hosted agents, it will be based on the subscription you use, I guess.
Yeah, and I take it you just pay for the image in the storage account.
Yeah, but you don't pay for the image. You also you pay for the so for Azure Virtual Desktop itself, you have the E3 Business Premium licensing to use Azure Virtual Desktop as an organization. Then you can, if you have those licenses in place, you can use that for connecting to the Azure Virtual Desktop. And for the image itself, it will only cost you some little amount of money to store the image in the region. And the shared image gallery itself will have some little consumption, not that much, but a little consumption to store data. And it all depends, because that's also the nice thing in this combination. If you replicate the shared image gallery where the image is stored into another region, let's say in North Europe, and you will have a disaster recovery of a disaster in West Europe. With this code, you can also very quickly redeploy in North Europe using the same image. So a lot of positive things.
Okay.
For cost-wise, it is not Azure Virtual Desktop itself. Only the session host will cost money if you deploy a session host based on that image. So yeah.
Have you deployed this on production before, or is it all like testing?
Production, yeah.
Okay. And it normally takes longer than it's 6 minutes.
Yeah, this is this project, but also this process is only being done once in your lifetime. Every time you so you don't do this step every time. This is only once, and then then I can show you that in one research group I already built. This is a pretty pod. So this is the end. This is what you have after the finishing. So this is the version, and this is being used by session host. So what you see in this section is building the image itself based on those scripts is only once.
Okay.
So yeah, that will take. That's the longest time. So the rest is quicker.
Okay, that's brilliant. So so we got the links, everything as well. So yeah, so it's probably you can probably just put this into like a startup process in order to start this up before in the morning and stuff and deployment, and then you just update the image if you want to update the image or if need to.
Yeah, you can put it that way. Yeah.
Okay, so we've got no more questions. So I take it you can just pretty much do the same way of in GitHub Actions as well. You just do the update images and you just pay. It will be roughly the same price in terms of cost.
Yeah.
Okay. Cool. Yeah. So we would rather let's not wait for that to deploy because you already.
No, that takes too long. But for now, I think you have a good idea how easy it is to deploy an Azure Virtual Desktop using pipelines.
Yeah.
I can't remember. Jan, did we also write this for GitHub Actions as well, or was it just?
Yeah, you can also. Yeah.
So if you go to the, I was going to say bicep repository, GitHub repository. It's been a day. If you go to the GitHub repository, you can look at all the code, and because we know that some people like to use either or, we went through and rewrote it all in GitHub Actions, so you can pretty much take it from there and then just tweak it a little bit. But it saves you hours of painstaking testing and troubleshooting to go, this is how it works, and you've now got a video to reference and see from there, really.
Yeah.
Sweet.
Okay. So what are some of the challenges in when you set up these demos and stuff, when you had to because remember before you said you had to stay up late to set its pipeline? Is it just getting everything working?
Yeah, it was just like the troubleshooting, getting the various like stages and jobs to pass values through, building the bicep param file using PowerShell based on the input parameters from Azure DevOps or from GitHub Actions, and then working out how that works. Then when we were doing the like conversion, I guess you could call it, from Azure DevOps YAML to GitHub YAML, they're very similar, but not. So you can't just cut and paste it. Then there's refactoring to do to get it to work in GitHub Actions. And then there's the authentication bits and pieces, which is slightly different to be able to get it to talk into Azure, which is one of the reasons why I kind of prefer doing stuff in Azure DevOps now, because you can get the service connectors using the workflow managed identity, which is really cool. So there's no credentials or passwords to set up. And I know you can do the same with GitHub Actions using the OAuth and OpenID things. But yeah, I just find Azure DevOps a little bit easier to use at the moment. It might be because I'm using it more for like day-to-day stuff with customers as well. But yeah, it was just, and then there's the whole like infrastructure as code and testing it in pipelines where you don't really have access to be able to just dig through the logs very easily. So then you do a bit in DevOps, then you do it locally, and then you try and get actions, and it's just piecing it all back together until you get to this point where we go, it works. Share it with everyone so they don't have to do what we did. So it'll save everyone else time, because we've done the miserable bit, and now you can just, like I say, take this and run with it.
That's brilliant. Or TTs, do you have any question for Simon and Gert? I just saw you still here.
I'm still here. So great presentation, guys. I don't have any questions. Just one small one. So regarding the triggers of the pipelines, do you have any other triggers other than manually triggering and passing the input variables that you like? I was thinking about I was thinking about the setup, let's say, for example, at first validating, let's say, with what if or something like that.
Yeah,
So the only problem with using the validator of the what if is it then requires like a manual. When you're doing it locally on like a laptop, for example, you've got to physically press a key enter to be able to do it. And there are ways that I've seen where you can like trigger Azure DevOps to be able to like require a user input, but for the most part, if someone forgets to do that, it obviously then means that it wouldn't run. That said, though, there are other ways to do like the validation. So you can use like the PS rule analyzer stuff, which Gert-Jan wrote a blog post on for Azure Spring Clean, which basically allows you to validate the bicep before it gets into production. So in theory, when you're in production, you should only have production grade code that's passed all the units test and validations and all the testing to the nth degree. So you just know that it works.
Exactly.
At some point, maybe we could come back, Nick, in a couple of months, once we've written it and put the code validation in front, and then we can here's part two.
That sounds cool. We can do that.
With the testing once we've worked out and spent more hours drinking coffee and writing code to music.
Yeah, always. No, that sounds lovely.
Okay. So we got no more questions. So I shared all the links anyway, so people got it.
Cool. Thanks a lot.
It should be okay. So let's wrap up then. So any more questions? So we got no more questions. So so thanks for joining, Orestis,
thanks for having us.
and Simon Gren. It was an amazing session. So it's amazing that you stayed on as well. I thought you was a bit late. So thanks. And
thank you for hosting us.
No worries. So our next session is on the 7th of April. I think it's Tim Warner and someone else. The second speaker has not been announced yet, so keep an eye out. And I think that's it.
Cool.
So see ya, everyone.
Thanks all. See
you guys.
Bye.
Thanks.
Bye. Thank you.
Bye.